Hi, my name is Yaniv, machine learning specialist at AWS. I help AWS customers to tackle their machine learning challenges. While machine learning and cyber fundamentals have a strong correlation, for instance, binary classification, malware or not, anomaly detection, malicious network traffic, etc., it's still day one for machine learning and cyber. We've observed the trend of growing adoption of machine learning rather than heuristic-based for a variety of cybersecurity use cases. During this session, we hope we will give you the knowledge and tools to innovate and build with machine learning. We have a great set of panelists here today. Kobi Sambursky, Managing Partner, Glilot Capital, will share his insights about trends and opportunities in cybersecurity. Afterward, I will talk about how cyber companies can innovate with machine learning. Matan and Ori from Imperva will talk about lessons learned from Imperva's ML journey. Kobi, I will hand it over to you.
Thanks, Yaniv. Hi, everyone. I hope everyone hears me well. So great to be here. It's been a while since we've been able to do face-to-face stuff, but it's almost as good. So again, thanks, Yaniv, for inviting me. I'm going to talk a little bit about cyber and a little bit about ML in cyber. And there's an option here, I think, through the chat. And please correct me if I'm wrong, but there's an option here to send questions. So please do so if you need me to say anything that I missed. So just starting very quickly about Glilot, we've been around for 10 years plus now. First cyber-focused fund globally, started investing early 2011, and really have seen the changes in the cyber market that evolved significantly since we started 10 years ago, and I'm going to touch it later. As a focused fund, we invest a lot of efforts to help portfolio companies and to become real partners, and we have developed through the years an operational model that allows us to help companies at every stage, seed stage and later stages. And this is one of the reasons why we became very successful, top performing fund globally, with many exits and companies that are going all the way. So this is us. Earlier this year, we have launched what we call Glilot Plus, which is a later stage fund. So today we can support companies both in the seed stage, which is our typical investment, and also on later stages. So virtually we can invest in every step of the way of your journey. So this is a bit about us. And Eve asked me to talk a little bit about moving. Yeah, so Yaniv asked me to talk a little bit about cyber today. And, again, we started 10 years ago, and probably if you would ask me 10 years ago when we started, or 11 years ago when we started to think about the fund, I would have probably said that the cyber trend will become slower by now. But what we've seen in the last couple of years is it's just becoming stronger. And I think the main reason is the cloud. I'm sorry if what I'm saying is almost obvious, but the shift to the cloud is a huge thing, and it's actually requires companies to build their IT from scratch, which also means that the entire security stack needs to be built on scratch. And this is creating very big opportunities for new companies. And I think you're all reading the news and talking with people, so you know some of the big names that are related to cloud security. Some of it is maybe a little bit exaggerated, and maybe the valuations are a little bit overflated, but the opportunity is real. When companies are building their entire IT from scratch, there is a huge opportunity to create multiple companies that are addressing this market. So this is one big thing. Another big thing is what we call shift left, which basically means developers are becoming more and more significant in the security domain. In the older days, it was virtually only the security team, the team of the CISO, that were responsible for the entire scope of cyber solutions in a given company. Today, it's becoming different as engineers, developers, DevOps get more and more a bigger role in this, which also calls for a new generation of cybersecurity companies that are not addressing only the security teams, but addressing at least also the developers. Those two trends, shift for the cloud and shift left or shift for developers, creating huge opportunities to create great companies, and I think those are maybe the main reasons why we are seeing such a huge uplift in cybersecurity, and this is also why we in Glilot believe that it will not end anytime soon. So I think the wave that we are in, it's so big and significant that it will take a while until until it will come to an end or come to a slowdown. The third trend is, again, Yaniv asked me about cyber trends. The third trend is, I have to admit that I don't know. I think in our business you have to be very humble. At the end of the day, we are learning from entrepreneurs, what they think are the new trends. I'm sure there's more stuff to come, and I can guess just like everyone else, but this is going to be only a guess. So I think there are probably other revolutions within cybersecurity that are waiting for the right team of entrepreneurs to reveal to us and to the world what's coming. So but I'm sure there's much more. So keep tuned. So this is about cyber in general. Now let's talk about machine learning, because we've been hearing about machine learning for obviously for a while, and to be honest, I don't really like when companies are calling themselves machine learning for cyber or machine learning for whatever, because I think machine learning becomes a basic building block. It's just like you're not going to say I'm going to build a cyber company around Kubernetes or whatever. So machine learning becomes a basic building block within almost any technology solution, specifically within cyber. It's never going to be the only one. So when you're developing a cyber solution, you will use other technology components as well. It's typically not going to be the first building block you're going to use, you're going to build. You're typically going to start with stuff that is more basic, more straightforward, more simple, maybe more easy to understand. And likely machine learning is not going to be the component that covers most of the solution. It will probably cover only a fraction of the solution. But typically what happens is that the component of machine learning will probably be your differentiator for the long run. So I typically look at machine learning as the cherry on the cake, or this one specific thing that on the long run will become your advantage in the market. And specifically when you combine machine learning and data, this is where things become interesting. So as you all know, machine learning depends on data, but it's also the great way to leverage unique data if you have it. So this combination of company that owns or has access to unique set of data and can leverage the data with a good layer of machine learning and AI can really create a barrier for the long run, probably better than a typical standard software barrier or whatever. So again, ML to me is not the only component, not the first component, not the widest component, but probably the most important component to create a long-term advantage. So what is machine learning used for within cyber? So along the years we've been working, we saw many different use cases for machine learning. When we started, again, about 10 years ago, well, probably when we started, there was not too much. Even in our first portfolio company, there was a component of machine learning. So yes, even 10 years ago, we saw the usage of machine learning. It was initially mostly for detection. So as I hope you'll agree, in today's advanced attacks are hard to detect. So most of the usage of machine learning in the early days was to detect attacks and to figure out that someone is attacking me, find anomalies within network activities or user activities or whatever. What we've seen in the last years is that the use of machine learning is getting much wider. So not just still in detection, but not just in detection, becomes much wider across the industry. And just to give you some examples from portfolio companies, but again, I'm sure there are much more. So examples, and I'm going to start from the left side. So Mitiga is an incident response company. So incident response, as I'm sure most of you know, is when I have an incident and then I know that something bad happened and I need to figure out very quickly what happened and to go back to full operation as fast as I can. So this is typically a very manual process. You typically, to have a good IR company, you typically employ great cyber people that really know forensic work, and they'll get into the customer side and they'll start collecting data, and they'll start figuring out what happened, so that to give you good advice as to how to go back to operation, and also how to prevent from such attacks happening in the future. What Mitiga is doing, they're using a lot of ML technology to augment the work of people. So in this case, it's not really to replace people, it's to augment people and help them do their job much faster. So Mitiga is about collecting the data on an ongoing basis and analyzing it so that when an event happens, the forensic analysts can do their job much faster and get the company up and running much faster. So this is one example of the use of machine learning outside of detection. Another example is Cardinal Ops, another portfolio company that actually looks at your entire cyber operation. So let's assume that you have already invested tens of millions of dollars in various cyber solutions, and you have your SIEM, you have your endpoint solution, you have whatever, dozens of other solutions. But as we know, in most cases, the solutions or the security setup is not fully optimized for the threats. For many reasons. One is because the threats keep changing, and the other is because your network and setup keep changing. So what Cardinal Ops is doing, they're analyzing your entire cyber operation, and they come up with and they know current threats, and then they come up with certain fixes to your configuration and to your setup to give you better coverage that suits more the threats and suits more the existing network and the existing IT setup that you have. So this is a very holistic view around your cyber operation and use of ML to also, at least for some extent, to augment the work of people, so that the entire security operation is going to be much better and have much better fit with the needs of the organization and the current threat. So this is kind of a holistic example. Another example is Hermetic, that are looking more into credentials and entitlement. So the vision here is that when the world is moving more and more toward zero trust and the network is less and less significant, the permissions that users and machines are getting is becoming more and more critical. And they're analyzing your the entire set of credentials within different identities within the organization. They analyze what's common, what's less common. They analyze, what people and what machines are actually, what entitlements they're actually using, and then they'll give you indications of how to maybe starting from the detection side, so activities that are not normal and you should pay attention to, but also entitlements that are not really being used, or credentials that have been forgotten and stuff like that, and allow you to improve significantly your cyber setup by limiting the amount of limiting the attack vector and also identifying attacks. So this is another example within pure cloud, and upstream, probably the most unique one. They are working in the automotive space. So the other companies that are mentioned are more generic, relevant to any company, to any organization. Upstream is focused on automotive, and they're actually analyzing the data that goes between the car and the cloud. As most of you know, or maybe, I don't know if most of us know this, but you should know that most cars that are getting, about 80% of the cars that are being shipped today have connectivity to the cloud, which means that every twice a minute or so, they would send a significant amount of information up to the cloud, and this information contains virtually everything that is happening within any sensor in the car. So you have dozens of sensors within the car, and they'll send those sensors will share their data up to the cloud. This is truly a case of big data, because if you have a fleet of a million cars and each one of them keeps sending all the information of the sensors up to the cloud, and you can sit on this data, you have an endless source of data that could be used for many different things. And the one that upstream started with was obviously cyber. So looking at all those sensors could give you a great indication if someone is attacking a specific car or the entire fleet. And funny enough, actually it's much better view than if you are sitting in a specific car, because you're seeing all the data from all the fleet at the same time. So you can correlate events, and you can figure out much faster and better if an event is happening. But cyber is just the beginning, because if you have all this data on cars, you can know if someone is trying to steal a car. You can know if someone is becoming sleepy behind the wheel, because suddenly the way that he steers or the way that he drives is a bit different than when he's full awake. You can know if there's a bump on the road. You can know if someone forgot his child. So this is, I think, a great example of this combination of data, unique data, and various ML layers on top of it that allows a company like Upstream to solve almost any use case, again, from cyber to fraud to problems in the highway to preventive maintenance and more. So just to give you an idea of how wide this could become. So that's about it regarding examples. Again, if you have questions, please let me know. And just to to sum up on this, ML to me is is almost given, in the sense that, you know, if I was to start a company now, I would definitely add ML as part of the solution. Again, I don't like when people call their companies ML for whatever, because ML is ubiquitous. It's an obvious component that you should use, and it's a component that probably is the one that will give you the edge for a long time. You know, it's becoming more and more difficult in today's market to create this technology edge that will allow you to win competition on the long run, just because, you know, there's so much funding and there's so many smart teams that are creating solutions, and, you know, whatever solution you have created, there's other teams that can raise a lot of money and recruit a lot of engineers and probably do something similar. But machine learning with the combination of data, specifically if it's unique data, can really give you an edge for longer term. So I think it has a very significant place in the role of every young company, and specifically in cyber companies. So I hope it was helpful. Again, if you have questions, please shoot them to me, and otherwise my email is here, so on the screen. So if you need to catch me on anything else, please feel free to do it. Thanks, everyone.
Thanks, Kobe, for sharing your insights. Hi, everyone, and again, thanks for joining us. In the next 20 minutes or so, I will try to share with you some of the insights we at AWS have seen with our customers. We will start with the problem framing and our methodology of working backwards. Why now? Why machine learning is becoming a significant building block in cyber solution. The evolution of machine learning for cyber, how to build a solution, types of learning and models, how to navigate the machine learning funnel, and the path for successful POC. Before we start, I want to share with you a personal story. 2 weeks ago, I took a taxi for a business meeting, and the taxi driver asked me, "Where are you working?" And I told him, "Amazon Web Services." And he told me, "Great, so you are shipping products?" And I told him, "Not really. AWS is the cloud service, and I'm working in the AI team." And he asked me, "Okay, so what is AI?" So I started to explain that AI is everywhere, in your cell phone, home, car, and even taxi, like Uber and others. Why am I sharing it with you? Because according to Gartner, by the end of 2024, 75% of enterprises will shift from piloting to operationalizing AI, meaning we are in the midst of this revolution. We are seeing many of our customers creating unfair competitive advantage with machine learning. Likewise, security challenges and machine learning fundamentals are aligned with various applications of machine learning in cybersecurity, like modeling user behavior, applying machine learning in endpoint detection and response products, automated network and system analysis, and more. The first step of innovation is to start with a problem. We at AWS like to call it working backwards. Start with the customer's pain points. CSA, Cloud Security Alliance, published in 2020 the top 11 threats for cloud computing to raise awareness of threats, risks, and vulnerabilities in the cloud. They surveyed 241 industry experts on security issues in the cloud industry. They rated 11 salient threats, risks, and vulnerabilities in their cloud environments. The leading threat is data breach. The most relevant example is the Kaseya ransomware. Revil Group launched 2 weeks ago a supply chain attack, and they've asked a record of $70 million ransomware, or SolarWinds attack. You can find here various threats. Attack vector can contain a combination of these threats. For instance, insecure API, which led to data breach, etc. This analysis can be a good starting point to explore potential security problems, account hijacking, insufficient identity access management, weak control plane, and future potential threats like data encryption, supply chain attack, and more. And this is the story reflected by the numbers. Average ransomware payment grew by 43% from Q4 2020 to $220,000. I assume many cyber companies will be happy to have this growth rate Q over Q. The leading attack vectors are RDP compromise, remote desktop protocol, which declined from 80% to 40%. Email phishing with 30% and software vulnerability. According to some of the analysts, 90% of the generated code is based on reusable code from open source, GitHub repositories, etc. This can be a significant threat, and you probably know a few local companies working in the API security domain. As security products are evolving, the attackers are not sitting on the fence. They develop AI-based attack vectors. They can potentially select the best vector attack designated for a specific industry. For instance, hospitals, running 24/7 and critically thinking about how to attack, execute successfully, and remain undetected. ABI-based network attacks can be defined as the process of using artificial intelligence in gaining unauthorized access to other networks with the intent of performing some malicious activity. This can be stealing of data, denial of service attacks, brute forcing networks or passwords, data poisoning, and evasion attacks. Hackers are developing AI-based attacking tools and techniques that can bypass the existing detecting system and can weaponize the target systems. Some of the common examples are passgun, molgun, deepfish, etc. Passgun, password generative adversarial network, is an advanced password guessing technique by AI. Generally, we know the traditional password cracking technique is to brute force passwords using a predefined set of dictionaries with linked passwords and rule-based approaches. This user has to give predicted data to feed the system to attack. With machine learning, machine learns the patterns of leaked passwords and not guessing the possible passwords. Molgun is an AI-based anti-malware bypass technique. This algorithm is based on generative adversarial network. Molgun is mainly focused on bypassing the machine learning-based black box malware detecting system. Molgun trains the network to bypass the adversarial malware. It minimizes the probability of catching malware in the network. Molgun adds additional noise to malware to become adversarial malware. Thus, Molgun fools the malware detecting systems and successfully penetrates the targeted network. Deepfish is the process of generating the most accurate phishing URLs using machine learning. Generally, phishing URLs are generated randomly by traditional processes or tools. But in the case of deepfish, URLs are generated based on deep analysis of previous successful attacks. This algorithm analyzes huge sets of data with the AI algorithm to generate high-value URL for phishing. Firstly, reconnaissance of phishing data on the database takes place. Secondly, the LSTM model receives the URLs that are effective and trains with these URLs. Thus, deepfish can establish phishing attacks successfully. And it's literally a race. This quote is interesting due to the fact that recently one of the biggest insurance carriers in Europe, AXA, announced that it would stop covering ransom payments under its cyber insurance policies. So now that we have framed and understood why it's not going to be easier, we will try to find the best way to countermeasure with it. Historically, security has been a very binary, rules-based system in which things are either okay or not okay. And we've built complex systems that define okay based on a number of criteria. But how can you face this challenge at scale? With more than 500,000 new malware types per day and more than 1 billion malware programs out there. Machine learning is designed to allow machines to learn from data as opposed to programming. Feature engineering and extraction is the phase in which we prepare the data for training. Usually it consumes the majority of the process time. Deep learning is a type of machine learning. Deep learning is about computers learning to think using structures modeled on the human brains. The adjective deep in deep learning refers to the use of multiple layers in the network. It works with structured and unstructured data like image and text, but there are a few use cases for cyber as well, like analyzing logs and code with NLP. One key thing I want to call out that sometimes a good mixture is to use human in the loop. For certain use cases, it can be a good practice to combine a human which will evaluate the machine predictions with mid or marginal confidence score. Let's take an example of malware classification, beginning with framing the question as an ML problem. As the diagram illustrates, you typically perform the following activities: generate and collect the data from internal and external sources of malware datasets. For instance, Sorel 20 million is a public malware dataset which can be used. Afterwards, integrating the data, preparing it, clean, removing outliers, visualize and analysis. Feature extraction is the next phase. An example can be either with dynamic or static approach. Static approach, one can use NLP to analyze the code and extract a feature vector. While dynamic approach, one can run the executable file with an emulator, use bag of words or n-gram models to analyze the logs and extract a feature vector. Training the model with different methods of splitting the train, validation, and test sets, tuning the hyperparameters, which is the core role of the data scientist. Evaluating the accuracy with various metrics, precision, recall, F1 scores. Is it good enough for launching into production? And if you think your job is over, then guess again. Now it's managing the model, monitoring the accuracy, data drift, managing the versions, expanded to multi-model, for instance, tailored model for industry like banks, manufacturing, etc. You can see some of the challenges in the previous slide in this machine learning magic matrix. We can break those quadrants down into the known knowns. This is the easy part, what your machine learning model can confidently and accurately do today. The known unknowns, things you are aware of but don't understand, what your machine learning model cannot confidently do today. Zero-day attack can be one example for it. The unknown knowns, things you are not aware of but understand, knowledge within pre-trained models that can be adapted to your task. For instance, we know the most of cyber attacks start at Friday noon because of weekend. And the unknown knowns and the unknown unknowns, gaps in your machine learning model where it is blind today. This is one of the examples of how to navigate with machine learning. Starting with the data. Is it available? What is the size? Tens, hundreds, thousands, or tens of thousands? Is it labeled? One of the biggest challenges is to get labeled data with an expert labeling. Afterwards, define the machine learning technique classification, clustering, classification, clustering, regression, and many more that are not in this diagram, like XGBoost, NLP models, and transformers. There are a few types of learning. Past trends, supervised learning. This is straightforward with labeled data. Ensemble learning, this is an extension of supervised learning, while mixing different simple models to solve the task. There are different methods of combining simple models. Current trends, unsupervised learning. This approach can be used when there are no labeled data, and the model should somehow mark it by itself, based on the properties. Currently, it works less precisely than supervised approach, for example, k-means cluster. Semi-supervised learning, as the name implies, tries to combine benefits from both supervised and unsupervised approaches when there are some labeled data. Future trends, reinforcement learning. Environment-driven approach can be used when the behavior should somehow react on the changing environment. It's like a kid who is learning environment by trial and error. AlphaGo is the first computer program to defeat a professional human Go player with reinforcement learning. Active learning, it's more like a subclass of reinforcement learning that probably will grow into a separate class. Active learning resembles a teacher who can help correct errors and behavior in addition to environment changes. One of the key takeaways is that you don't have to be machine learning PhD. Advanced machine learning platforms enables to increase the productivity and reduce the time to market with tools like AutoML, automatic model tuning, training, debugger, etc. One of the ways our customers reduce the machine learning heavy lifting is with SageMaker. SageMaker is end-to-end machine learning service with a lot of different features and capabilities in it. You can find here solutions to the majority of the machine learning pain points. Data wrangling, feature store, explain the AI model, AutoML, in which you just give the data to the machine and it will automatically train and find the most accurate algorithm and the most accurate hyperparameters. Automatic model tuning, debugger, spot training, model management, model versioning, model monitoring, and the feedback loop. Sometimes we recommend our customers to use machine learning for business use case. And sometimes it's overshooting. Machine learning can be a good fit if it's easy to explain with examples and hard to build a formula. Data scales very fast, like the example we mentioned before of 500,000 new malware types every day. On the contrary, if it can be solved with if and then logic, requires full explainability, it's not the optimal, etc., and it's not the optimal solution. So maybe it's probably don't use ML in this scenario. Some of the classic use cases, and this is our examples, and there are many more, are malware classification, anomaly detection, threat scoring, NLP for log or code analysis. To recap, we talk about working backwards. Start with the problem rather than develop solution and look after a problem. Is the data available? Do we have enough data? Afterwards, we talk about the solution, types of learning, types of data. It goes without saying that a good practice is to start with an MVP. We talk about how to leverage SageMaker to manage the experiments, A/B testing, compare model, improve the accuracy, and deployment at scale. And the most exciting part, launch it to production. Build an improvement mechanism with real-life data, feedback loop, tailored models per customer or industry. I hope you learned during this session. We at AWS will be happy to support you. Feel free to send us a note on floor 28, COIL, or send us an email. You can move forward and build your own POC, and AWS can support with credits, technical support, etc. It's a big pleasure to host Matan, Data Science Manager, and Ori, Principal Engineer from Imperva. We are working on a few quite interesting projects, and they will share some of them with you. So without further ado, I will hand it over to you, Matan and Ori.
Hi, thank you for joining this session. Really happy to be here and share some machine knowledge with all the cybersecurity community. My name is Matan Leon, and I'm leading the data science team at Imperva. Joining me today is my peer, Ori Nakar, Principal Engineer at the Threat Research Group. Today in this session, I'm going to walk you through the data science process at Imperva and also demonstrate them through a specific use case of botnet detection at scale. Let's begin. For those of you who are less familiar with Imperva, we provide security coverage for threats from within your organization and from the outside. The threat landscape includes network attacks, such as distributed denial of service, application layer attacks, such as remote code execution and application logic manipulations, and also threats on the data layer, such as data exfiltration. To protect against those threats, our solution is layered into several components. The edge security layer, including network protection to DDoS attacks, application security layer, including web application firewall solution, account takeover protection, client-side security, API security, and more. And also for an end-to-end coverage, we also provide data security layer, including both on-prem and cloud data protection. Each of the security solution provides some data that we can collect and use. For example, on the client side, we have the ability to monitor tools and resources used by the end users. On the edge and application side, we collect traffic statistics, attack data, and additional meta information from different reputation services. Finally, from the data security product, we collect where possible audit data, which we use to monitor suspicious database activity. Let's have a closer look at one day of worth of data that flows through our pipelines. We have more than 40 billion HTTP requests inspected by our security solution each and every day. More than 4 billion malicious web application attacks mitigated by our solution and originating from more than 500,000 IP addresses. We also detect and mitigate more than 600 DDoS attacks a day that last on average 1 single hour. However, perhaps the most interesting fact here is that the daily web traffic that flows through our pipelines has increased by 50% since last year. This increase shouldn't come as a very big surprise. Online services was growing fast before COVID-19 hit, and the pandemic just pushed even farther with more consumers and physical services going online. However, from a technical point of view, this increase does stress the importance of flexible and scalable data infrastructure to support this kind of trend. To properly store all this data, we use AWS Managed Data Lake Storage. We chose data lake storage for several reasons. First of all, it is entirely agnostic to data types and doesn't require a predefined data scheme, which are both super important if you are researching and looking into multiple data sources, just like we do. Also, since it is based on object storage, it is easily scalable and cost-effective. All right, let's have a closer look at our data pipeline. To comply with data security regulations, our data pipeline is distributed across 4 different cloud regions. In each region, we first consume the data from different data sources using Kafka queues. Once consumed, the raw data is stored in dedicated S3 buckets. Then we process the data into an aggregate version for improved storage and query efficiency. Overall, to process all the data, we run about 200 ETL jobs on different daily cages. As you can see on the right side, using a data lake enables us to use different query engines. In our case, it's Amazon Athena and Apache Spark, which are then available to different clients such as Python SDKs, query engine clients, and web-based notebooks like SageMaker Notebooks and Apache Zeppelin. Now that we have the data pipeline covered, let's talk about some of the considerations and challenges we face when working on a new machine learning project in the cyber arena. Let's start with some data considerations. First, in many of the use cases, we just don't have labeled data. This is a rare ingredient. Labeling the data is sometimes an option, and we'll talk about it in a bit. Privacy, of course, is always top priority. For example, in many of the cases, we have the needed data, but most of it is either hashed or masked. In those cases, we still need to be creative and find a way to extract the needed value out of the data. One possible option is to move some of the machine learning tasks, like the feature engineering, closer to the origin as possible. For example, in our use case, it can be pre-processing the data on the user side or within the proxy. Let's move to some model consideration. One important question to keep in mind is whether or not we can explain our results. Providing a reasoning to a machine learning decision could be a great motivator for a user to take action, and it can also be a very useful tool for the data scientist during the research process. Let me give you a specific example. When we work on a database security solution, we try to provide information on general database anomalies. It didn't work. The customer were looking for specific security incident that they can actually translate into actions. Today, we provide specific reference to the suspected attacks and additional attribution information that can be used for a follow-up action. Two more factors that goes hand in hand are the latency required to get into a conclusion and the security action that should be taken. We'll talk about it more in a bit. Lastly, since we deal with many security projects involving different teams and technological stacks, we need to decide what kind of artifacts the data scientists will deliver. In some cases, we are working end-to-end, providing machine learning insight directly to the product, while in other cases, we'll choose to spread the responsibility between the different teams and deliver intermediate artifacts. All right, let's have a closer look at some of those considerations and challenges and see how we actually solve them. When talking about latency versus action, we have quite a few projects we started in the third quarter, which means that we perform the analysis offline. Few of examples include clustering botnet, as we will show later on, clustering API traffic into endpoints, and detecting suspicious DB activities. Note that the closer we go to the online process, it basically means that the offline detection process is shorter and near to real time. Based on the offline detection process, we can actively take different actions. We can take immediate action offline, such as marking malicious IPs for mitigation or adjusting the database configuration to prevent future risk. We can also use the offline artifact to prevent online risk by using, for example, pre-trained model to evaluate the risk of incoming web traffic. Online detection is also a valid security approach and could be used to support customer decisions. For example, we use this approach to cluster overwhelming amount of web attacks into meaningful stories in which the customer can digest and further analyze before taking action. We will talk about this approach in more detail later on when diving into the security use case of botnet detection scale. Another crucial consideration to take into account is the nature of the data and the type of machine learning algorithm to go with. As mentioned before, in many of the cases, we don't have enough or any labeled data. In those cases, we'll go with unsupervised models. Of course, that if we have enough labeled data, we'll go with supervised models. To move the needle from unlabeled to labeled data, we often try to hunt the ground truth using different ways. One great option to work that works is using customers' feedbacks. This is the most important and accurate labels you'll ever get. However, customer feedback related to security events tend to be specific, which is not enough for supervised learning, and therefore we mostly use it to verify our own results. In many real-life problems, datasets are extremely imbalanced. Security data mostly include normal samples, which make learning the abnormal cases really challenging. It is possible to balance these data sets by synthetically creating new samples. However, because of the complex nature of the data and based on our experience, generating meaningful samples is quite challenging. Another option that could lead to supervised models is by using external sources. We use both external data sets for training and pre-trained models for transfer learning when possible. Expert tagging is also an option. It can be SOC engineers, security experts, or any expert that understands your problem and data and can classify it efficiently. An approach that we are taking quite often and find useful is using our own security solution as a security experts. We use decision taken by the product as the ground truth, which can then be further extended using techniques like active learning. Well, looking back at previous tasks that we already solved, to actually move the needle to supervised learning, not one, but a mix of those approaches are actually required. Moving to how we actually do machine learning. We divide our process into two phases, the data playground and the machine learning pipeline. In the first phase, we use Amazon SageMaker notebooks to explore the data and think through the previous discussed challenges. Anyone who tried to share Jupyter notebooks or use notebooks belong to others probably know that it could be a burden. Often, you just don't have access to the required notebooks. In other cases, the code is just broken, using, for example, Python packages not installed on your own environment, or requires data that is just unreachable and can be copied to your environment, for example, because it's too sensitive. Using a managed notebook environment solves this problem and enables us to collaborate easily by sharing notebooks and managing our project in one single place. Now, beside the notebooks being in the cloud and accessible from everywhere, it also provides elastic resources management and therefore enable us to focus on what really matters, which is data science. For example, we can create a small and cost-effective notebook instance for the initial phase of data analysis on a small sample dataset. Then, on a more advanced stage of the research, we can quickly increase the instance's memory to hold a larger amount of data samples within a single data frame. Also, SageMaker notebooks include a plug-and-play integration with other services that we use on a daily basis, including Amazon Athena and external services like Git for notebook versioning, which makes our life a bit more easier. Once the exploration phase is done, we move to the machine learning pipeline. The pipeline is responsible for every machine learning project lifecycle that we implement. The flow includes several steps that repeat until convergence. First, we query the data and pre-process it to better fit our problem in hand. Then we move to what we call the detection phase. In this phase, we process the data into feature metrics and then run the machine learning model. When training is done, we evaluate the results and compare them with previous runs. Each run is referred to as an experiment. Once we selected the preferred model, we deploy it in production and monitor it based on predefined KPIs. Based on the monitoring results, we circle back to tune and adjust the model as needed. From feature selection to model tuning and evaluation, experiment takes a lot of research time. To train, tune, and fail fast, we query and store the intermediate artifacts, including hyperparameters, and the output result for each step into our data lake using Amazon Athena. This process enables us to initiate each step faster based on stored artifacts from previous phases. To quickly scale CPU and memory, we run multiple experiments using Amazon SageMaker training jobs. Additional frameworks that we use as part of the machine learning pipeline include Docker containers deployed in Kubernetes clusters that are used to deploy models in production. We also use different data analytics tools such as Apache Zeppelin and Amazon QuickSight to monitor the model's performance and to evaluate its results. Okay, let's connect the dot and watch how the machine learning pipeline works in action.
Thank you, Matan. I'm Ori from the Threat Research Group at Imperva, and I will now give an example of our machine learning pipeline in action. Imperva WAF detects billions of attacks every day. It identifies and blocks malicious traffic. It also classifies the traffic into human and bot traffic. As you can see, 1% of the traffic is considered malicious. Most of the malicious traffic is done by bots. Bots are also performing legitimate traffic, like API calls between services. And there are also good bots, like search engines. Attack Analytics is an engine inside of WAF. It clusters attacks online into meaningful narratives. As an example, it can cluster many attacks coming from the same network with the same attack vector, client, or any other of the many features it uses to do the clustering. Botnets are internet-connected devices that perform repetitive tasks, such as distributed denial of service. I will explain more about our data and how we detect botnets based on it. WAF attacks have a single IP. Attack narratives have one or more IP and normally group many attacks together. Botnets have many IPs. We would like to use the narratives data to detect botnets. We have in our process two clustering algorithms. Attack narratives are clustered online and incrementally in the scope of a single site. Botnets are clustered offline using a batch process. The input data is the narratives data from all sites in a wide time range. As you can see, these are two different programs. We will focus on the botnet detection one. As explained, our pipeline consists of three main stages. We first query the data from the data lake and do initial processing by SQL using Athena. Then we perform additional processing and clustering using SageMaker jobs. Last, we write the results back to the data lake for evaluation. We will go over the steps in our example. In the first step, we query the data from our data lake. We let Athena find pairs of IPs which attack together. We include features about the pairs, like the number of times they attacked together. Data is later saved in S3 for the next pipeline steps. This allows running the pipeline multiple times without having to query the data. Next is the detection step. Based on the IP pairs and features, we calculate a distance matrix. Then we run a clustering algorithm to detect the clusters. We are using SageMaker training jobs to do the processing. It allows us to use instances with the needed CPU and memory resources. It also allows us to run many experiments in parallel. As you might have noticed, both the query and the detect parts are performing processing. It is up to the data scientist to decide whether to use SQL or Python. Performing operations by SQL can save time and costs. For example, we can let Athena find keywords in large text to avoid data transfer between the steps. Python, however, is more flexible and has many libraries and makes it possible to perform any processing operation. Back to the pipeline. In the last step, we evaluate the results. The experiment's results are saved back into the data lake. Here, for example, you can see different experiments and clusters. We define how to score an experiment. We can use known metrics like the silhouette distance, or we can join results with other datasets for custom scoring. We will give an example soon. What about testing? Pipelines are based on code. Code should be tested, even if it's written by a data scientist. Integration tests can be, for example, running SQL on a test database for creating a basic model. The test will check how your pipeline integrates with the data source. ML test will check dynamic and static datasets. You will use metrics like accuracy or F-score and your own custom metrics to measure your model's quality. It will allow you to progress fast or fail fast, knowing the cause of the failure. Remember, testing saves time. Now that you have an end-to-end working pipeline comes the hardest part, running experiments. We improve our clustering results by changing our pipeline. For example, we can decide to filter some of the data, to change the distance function, the algorithm, or a hyperparameter. Each experiment holds its set of parameters to allow easy comparison. A good pipeline will enable you to experiment or fail fast. After running some experiments, we will need to compare the results. Here, for example, we joined the clustering result with the next day's narratives data to find out if the IPs continued to attack together. We used QuickSight for data exploration and visualization. Here you can see multiple experiment results with statistics and custom scoring indicating the cluster's connectivity. The better scores are colored in green. After running multiple experiments, we get to the results we want, or at least know where we stand in our ML project. When a model gets to production, we monitor it using the same metrics used during development. Experiments are used again for updating, fixing, and improving the model. If, for example, we see a drop in the botnet's number, size, or IP connectivity, we run experiments to fix it. We can decide to query only IPs with more common sites, change the distance function, clustering algorithm, or a hyperparameter. In conclusion, having a fully automated pipeline will raise your model's quality and save you time both in development and maintenance. Thank you.
Thanks, Ori. So we talked about how we do machine learning in Perva and demonstrate the specific use case of botnet detection at scale. We want to wrap up this session with some key takeaways that might also be useful for your next machine learning journey in the cyber arena. First of all, based on our experience, there are common considerations that should be addressed when moving to a new machine learning project. Answering questions on early stages like, can the end user understand the reasoning behind the decision? Do we have enough information regarding the anomalies we're looking for? And should the model be used for decision support or decision making, all would likely to get you faster to the right security solution, while taking into account possible limitations. We also mentioned that the ground truth is a rare ingredient for most of the security real-life problems, making supervised learning less relevant. However, using a mixture of heuristics such as external sources and product baseline could in many cases bridge this gap. Moving to some technical takeaways based on our own experience. On the data side, data lakes are definitely the way to go if you want to scale fast and do intensive research work that require high flexibility. Also, utilizing a managed web-based notebooks like SageMaker Notebooks and Apache Zeppelin could provide a great leap toward knowledge sharing and collaboration. It is also worth noting that since we already used a unified data lake, the value of using a managed notebook was immediate for our own use case. Finally, when considering a full machine learning flow, we suggest to build a pipeline that will suit your own needs. In our case, we focus on three main phases: query, detection, and evaluation. All phases are supported by the data lake that is used to store intermediate and final results. It's important to know that one of the most time-consuming tasks in machine learning is refining your model. Therefore, a great way to test your machine learning pipeline is to measure how fast you can iterate between experiments. A well-designed pipeline should enable you to fail fast and move forward. Thank you.